So in this mini lecture video, we're going to talk about how do we experimentally determine these kinetic parameters that we've been talking about so much, specifically Vmax and Km. And the way we do that is with something called a Lineweaver Burke plot. So Lineweaver Burke plot. You'll also hear these referred to as double reciprocal plots. Double reciprocal plots. So essentially what we're going to do is some math to the Michaelis-Menten equation, and that's going to allow us to plot out and get a straight line, right? We always want to get straight lines. It makes it really easy to figure out numerical values. So if we look at the Michaelis-Menten equation, so here it is, yet again. Hopefully after you take all these notes, you just know what this is. And the first thing that we want to do is flip each side. So we're going to take the inverse of each side of this equation, hence the double reciprocal plot name. So 1 over V0 equals Km plus the concentration of substrate over Vmax times the concentration of substrate. Now we're going to separate out our terms on this right side of the equation. So this is equal to Km over Vmax times the concentration of substrate plus the concentration of substrate over Vmax times the concentration of substrate. So we can't do a little cancellation here. So now if we simplify, we've got 1 over V0 equals Km over Vmax concentration of substrate plus 1 over Vmax. And hopefully when you look at this, you see this as Y equals this term, which is M, 1 over the substrate concentration then becomes X, and our B term, our Y-intercept, is in fact 1 over Vmax. So what we can do then is measure the initial V0 as a function of the concentration of substrate. So we change the concentration of substrate and we measure the corresponding initial velocity. Then we plot 1 over V0 versus 1 over the substrate concentration. And from that data, we will get a straight line. So it looks something like this. So this is 1 over V0. This is 1 over the concentration of substrate. We get a line that looks like this. So the y-intercept, we already said from our equation, was 1 over Vmax. We know that the slope of this line, then, was equal to Km over Vmax. And in fact, if you went back and you plugged in 1 over V0 equal to 0 and solved for the x-intercept in that equation for the line, you would find out that the x-intercept was equal to minus 1 over the Km value. So now we can directly measure both Vmax and Km simply from doing a series of reactions where you vary the substrate concentration and measure the reaction rate, the initial reaction rate.